All right, we're looking at number 9 and 10 on review 1. So both of these problems deal with rationalizing the denominator. So remember, when we rationalize the denominator, it means we want to get any roots out of the denominator. So if we look at the first question, we are rationalizing with a square root. So we're allowed to multiply anything we want to a number as long as it's equivalent to 1. So what that means is whatever I multiply to the top, I have to also multiply to the bottom. Now for a square root, I can always just multiply by the exact same thing. So if I do that, I'm always going to end up with something squared underneath my square root. So in the bottom, I get square root of 15 squared. On the top, I get 5 square roots of 15. So the square root and the square basically cancel each other out, and I get 15 on the bottom, 5 square roots of 15 on the top. Now when we're thinking about simplifying, these are the numbers that we're looking at. We don't have any plus or minus signs. So since they're both divisible by 5, I can reduce that, and that will be the square root of 15 over 3. Okay, so what I've done is I've given myself something that is equivalent to my starting value, but the radical is in the top instead of the bottom. Now for part B, this one is a little bit harder because it's a cube root. So for this one to get a perfect cube, I need everything to be in groups of 3. So if I go ahead and break down what I have 49x, which is 7 times 7 times x. So what I'm thinking is let me move that. I have 2 7s, and so what I need are groups of 3. So when I pick what to multiply by, it does need to be a cube root. I'm thinking if I have 2 7s, I need one more. Okay, so I'm going to put that 7 there. I have 1x over here, so I need 2 more. So the idea is I should have 3 7s, and I should have 3 x's. All right, so if I go ahead and write that out, that'll be the cube root of 7x squared. I have to multiply by the same thing on the top and the bottom. So on the top, that just becomes 11 cube roots of 7x squared. Now on the bottom, when I multiply this out, I don't know 49 times 7 off the top of my head, but I do know that this is 7 squared times 7, which is just 7 cubed, and then x times x times x is x cubed. So if the exponent and the root match, we know that that's just going to come out to be 7x. All right, so this time I don't have any common factors. I'm looking at the 11 on the outside and the 7 down here. They don't have any common factors except 1. So, oops, just kidding. That's simplified, and that is my final answer. Now for the next question, I am looking at binomials on the bottom. So for here, when I want to rationalize the denominator, I'm going to multiply by the conjugate. So remember, to get the conjugate, you have to change the sign on your binomial. So for the first problem, I want to multiply by the square root of 2 plus 3, and I have to do that top and bottom. Now these are binomials, so when I multiply, I do need parentheses around them. All right, so let's see what happens. On the numerator, I get 14 times the square root of 2 plus 3. Now if I want, I can distribute that through, okay, or I can leave it out for now. On the bottom, I have to FOIL. So square root of 2 times square root of 2 gives me square root of 4. The outside gives me positive 3 times the square root of 2. The inside gives me minus 3 times the square root of 2. And then my last term is a minus 9. Now when you're multiplying conjugates, what you should always see is those middle terms should cancel. So we get 14 times the square root of 2 plus 3. And on the bottom, not only did those cancel, but I'm left with 2 minus 9, since square root of 4 is 2, and that gives me a negative 7. So the nice thing about leaving that 14 out is it's already factored out. So now I can reduce. So 7 goes into 7 one time, so that leaves me negative 1. 7 goes into 14 two times. Now this is not considered fully simplified. Because the bottom is just a negative 1, I can pull that negative up, and that becomes negative 2 times 2 plus the square root of 3, and then I don't have to write the denominator. So this is an acceptable answer, or I can distribute and get negative 2 square roots of 2 minus 6. All right, so let's try B. Okay, we know we want to multiply by the conjugate. So we're trying to get rid of the radical on the bottom. So we want the conjugate of the bottom, not the top. So 3 minus the square root of 7. So on this one, I'm going to have to FOIL the top and the bottom. So let me move this over. That's going to be 15 minus 5 square roots of 7 minus 3 square roots of 7 minus the square root of 49. When I FOIL on the bottom, I get 9 minus 3 square roots of 7 plus 3 square roots of 7 minus the square root of 49. Now a temptation you might have is you see these matching numbers right here. Actually, that one matches there. And you may want to cancel those. You actually can't do that, so don't cancel. You can only cancel factors, and these are terms. So if I clean up the top, notice this becomes 15 minus 7. Okay, if I replace that. So that would give me 8. And then if I go ahead and put these terms together, that would be minus 8 square roots of 7. Actually, wait. I messed up. All right, let me back up. So where I messed up was when I FOILed right here, a negative times a negative. That should actually be a positive right there. All right, so caught my mistake before I messed it up too badly. So that's actually 15 plus 7, which is 22. All right, now I put these together and I get minus 8 square roots of 7. On the bottom, those middle terms cancel, and I'm left with 9 minus 7, and that gives me a 2. So when you're getting ready to cancel, what you're looking for are common factors in all three places. If I see that, in this case, everything's divisible by 2, that means I can factor a 2 out of the top, and once it's factored out, then I can cancel. So on the previous problem, if I back up a little bit, we were able to do that right here because that 14 was already factored out. So on this problem, we did have to factor the 2 back out. So that gives me a final answer of 11 minus 4 square roots of 7.